record this. Hopefully it's not awful. As probably many others tonight, I have not had a ton of time, and maybe is could have used a little more time. But that said, we will charge forward. So my name's Rob. I am a developer from South Bend, and this is actually the project I'm going to talk about today was something I actually did as an independent study as I finished up my master's degree down at Indiana University in South Bend. And what I'm going to show you, I wanted to make sure I had enough time for this. I saw someone else took a couple time blocks, so I want to make sure I gave you guys a proper treatment of it. If you get bored with it, don't like it, I won't take offense if you leave and go to another session. But basically what we're going to...
So much for stealth.
So basically what I'm going to do is I'm going to go over, for those of you who aren't familiar with Node.js, a little bit about what it is, some of the libraries that I found extremely useful to build a multiplayer game using Node.js. And then I actually took the project that I originally wrote, which was about 1,200 lines of code, and gutted about half of it out so that we could grapple with some of it here and see if maybe I can show you guys something so you can go home and do some yourself. I'm sure somebody has a better idea than what I actually built and can do something interesting with it. So if you'd like, by the way, and it'll be available on the last slide, I have the website where the real version's fully deployed up there, as well as my GitHub account. This whole project is available on there. There are two branches. The master branch is actually the full website in a previous form without the sidebar. And the second branch, rollback, is actually the code I'm going to be showing tonight. So I wanted to give a special thanks both to my employer who let me cut out at noon today because I was driving up here, and then also to my wife and 3-month-old child who are at home without me tonight, which is also why I will only be here tonight and not tomorrow.
What's your node?
What's that?
Your newest node?
Yes, the newest node in the graph. So, as I mentioned before, our goals are to get an intro to Node. Some of the other frameworks that I've used are Express, Socket.io, and EaselJS. And there's some other ones mixed in there, but those are the key ones. Talk about some basic setup in case you haven't already installed Node, or if you have, where to go from there. And then review some of those key code chunks. So Node.js, how many here have heard of Node.js? That's a good start. How many have installed Node.js? Still good. How many know what Node.js actually is? I should have asked that one in the middle there. So Node is a web server framework that allows you to actually run JavaScript on the server side. Typically, we hear JavaScript is this language of the web, and people love it, hate it, kind of thing. You have to work with it because it's the only thing that's really available in the browser. And Node.js seems to be this movement towards, or the use of Node.js is this movement towards embracing it as something greater than that, and saying, hey, why don't we can use the same object notation on the front end and the back end. And we can reuse code chunks like, hey, I wrote this great library for generating unique IDs. Well, how about I ship it to the front end and I can generate those unique IDs on the front end and then ship them back and generate other unique IDs in the back end. So it's something that's really brilliant, and it's actually built on Google's V8 engine, which is the same JavaScript engine that runs inside of Chrome. It's currently used, I'll just kind of read the awful text block from their website, but it's not awful, it's awful that I'm reading it. But basically, it's great for building fast and scalable network applications. It's known for actually scaling fairly linearly because you can just fork off more processes and then you just back it with Redis on the same server, or a bigger database crossing multiple servers, and suddenly you can just run as many processes of it as you want. But it uses event-driven, non-blocking I/O, so it's great for things that need to be fast, things like APIs, real-time communications, multiplayer games, which is why I'm talking about it. Makes it efficient, even though it's still a scripting language. So Express, who's here? Is everybody here familiar with MVC as a concept? Show of hands. So those who aren't, MVC is essentially a way to segment design of a website or more a web application. You're able to describe your objects in models, you're able to describe how they should be presented in views, and you're able to wire up how it's all supposed to come together with your controllers. And so MVC frameworks often provide things like routing. Like if you've ever noticed on websites how you don't have to always see .html, .aspx at the end of things. Things just seem to terminate in like a slash. And how does that happen? A lot of those are usually due to advanced web servers or MVC frameworks providing those kinds of fancy routing things. Express also includes some other fancy new things. Ross Hunter, I don't know if any of you guys attended his talk on CoffeeScript earlier, but two of the things that they're similar to CoffeeScript as far as what it does for JavaScript is Jade for HTML templating, and Less and Stylus support is in there for CSS preprocessing. So I'll show you a little bit of Jade, for example. Basically, if you've seen some HTML, the tags, you have to open the tag, you have to close the tag, you have to make sure everything's just right. Jade allows you to drop the closing tags. It allows you to whitespace delimit your chunks so that you can more easily and clearly see what's nested inside of what. And you essentially write less keystrokes. And CSS preprocessing, it's probably easier for me to just tell you that's a whole other talk. Check out Less and Stylus because they're extremely powerful for making your CSS more efficient. There's also stuff in there for sessions and compression and static files and all kinds of fun stuff. There's other add-on libraries for things like authentication. So Express is extremely powerful. It's probably one of the most popular MVC frameworks out there for Node. So this slide here, the big things you need to do to get started. If you haven't already installed Node.js, hit up their website. They've got install instructions for every platform out there. They have what they call a package manager, which is NPM. It's something that the Ruby community has moved largely towards, and .NET communities have started doing it with NuGet. But basically, if you need a library, typically it used to be you had to go out somewhere and download it and then install it and do all these things. And instead, now you can just say, hey, I want this package. I heard about it. Here it is by name. Pull it straight down and import it into my project. It's something that makes grabbing all these things and deciding what to use in a project a lot easier. So we end up using NPM actually to bring in Express because it's something that sits on top of Node. So I put in the command line usage for that, NPM install Express. And the -G is a global flag, which means that you don't have to do this for every project. If you're planning on doing plenty of Express applications, you hit -G and it installs everywhere. So once you want to start a project, you type Express. And actually, just Express will start up a project. I personally prefer less support. We're talking about the CSS preprocessors. Less was actually the only reason I liked it better was because my IDE supported Less and not Stylus without extreme pain. So I wanted the syntax highlighting, so I picked Less. So basically, you do that, and it goes through and essentially runs a script that builds the directory structure, establishes your basic file that you can run immediately, and you now have a web server running. So it's very fast to get started. I mean, we've now said 2 things on the command line, and we now have all the files necessary to start a web server. Just a little bit about the structure. It's going to give you an app.js file. That's your main server code. So that's where the actual server's established and some of your routing gets started in there. Static files all go in public. I believe it usually gives you 3 directories up front: images, a JS, and style sheets directories, and so that you can segment those different pieces. And then your views are all in Jade, and they're stuck in the views directory, and routes hold your controllers. And just all you have to do to start it, node, app.js, hit enter, and it's up and running. So Now we're at three lines of stuff on a command line, and we're running a web server. You can see why people are starting to adapt this kind of thing, because the deploy, actually I just redeployed my website today. I copied the files out through FTP. I went out, SSH'd out to the server, ran basically those lines of code, and closed the connection and walked away. My server's back up and running. So there's one other thing, and I don't remember, I'll be honest, I don't remember if the starting in Express project does this automatically, but it's a file called package.json, and this is another thing that actually makes doing things with Node and NPM really special, is that you can essentially define a JSON object, and if you're familiar with JSON notation, it's standard JSON notation, that you can go out and say, this is the name of my application, I can give versioning to it, I can say, these are the most important thing about this really is in the second line where it says dependencies. I can now say I'm dependent on Jade project, I'm dependent on Express, I'm dependent on Mongoose, which is a MongoDB driver, ORM kind of thing. You can just say, hey, these are the things I want. You can even say what version numbers. In this example, I didn't do any version numbers, but you'll see that, like, for example, J here, I'm allowing any version. You can say I want 0.3.x, and that'll allow any 0.3 release with any further version number, but you don't want to pull anything beyond that because it may have breaking changes. So you can select some give to your versioning or a lot of give to your versioning. And then to make this happen, basically you create this file, you type the stuff in that you need, and then you just say npm install, and it goes out and grabs all the packages and all their dependencies. If anyone here has used a lot of Linux command line stuff, this is a lot like the beauty of using apt or yum to just say, hey, I need that package, and it knows everything else it needs to go get to build the infrastructure. This is also nice because it makes your deploys lightweight. The actual code to run my website is probably in the order, I don't even remember what the size of the directory structure is, but it's far more than I want to sit and wait for to copy over FTP. The actual code that I wrote is 300K, so I can deploy that and then go out to my Amazon Web Services instance, which has a much faster internet connection than me to it, and say, go get all my packages, and it fills them in. So npm install goes out and gets those. There's other instructions like npm update, I believe, will go out, and if you haven't updated those packages lately, it'll go grab the new ones. So now on to the more interesting stuff. Socket.io is a library that we use here. We talked about how it's great to be able to use the same thing on both the client side and the server side. Socket.io is our real-time communications library. So has anyone heard of WebSockets? Anyone familiar there? So this uses WebSockets, which is essentially a web browser analogy to the way we've typically made real-time communications available on computers. There's also fallback to things like if the user doesn't have a browser that supports WebSockets, but they have Flash installed, it can use Flash's sockets, it can do AJAX polling. It has a whole list of graceful degradations that are, most reliable to least reliable. And it aims to basically allow you to use the same code on both the front end and the back end. It's really slick stuff. And then express.io was something I used to cheat a little bit, because you start saying, well, I don't know, the first time, this was actually one of the first times I actually did a really big JavaScript project, really first time writing a lot of JavaScript at all. So I'm trying to tackle a new language and a new server framework and a new MVC framework, and you start to see this stuff pile up. I couldn't tell you who it was that wrote express.io, but basically this person took Express and took the socket.io concept and said, I want to make my routes for my real-time stuff look like my routes for my individual static pages. So he married those two together and essentially gave us something that is a little bit easier to swallow up front in terms of the syntax. And so that's actually what I'm using here. And it also simplifies the setup. This right here, in a very highly simplified manner, not counting the J and things like that you actually can set up. This sets up a web server. That's it. You require in express.io, you execute a couple methods that ends up giving you a server object, and you tell it to listen on port 3000, and you now have a working web server. So EaselJS is something I use for the front end. And this, has anyone here ever worked with Flash? Nobody likes to, and I understand if you don't want to admit it, it's okay. Nobody ever wants to admit that they, anymore today that we've worked on Flash. I have worked on Flash more than once. I know I should be ashamed. But it gives us a comfort point. Those who have worked with ActionScript, you know how the stage works, you know how animation works in Flash. And EaselJS was essentially a port of that kind of syntax into JavaScript, working with the HTML5 canvas element. So they gave you the stage, they gave you layers, they gave you the animation. They also put together libraries for sound, for resource preloading. So you can put up a progress bar and it can preload the resources and do all these great things, and you don't have to think about it. Createjs.com, you can pick up some of their packages there. In addition, I use Lodash, which is a drop-in replacement for underscore, if you're familiar with that. For those of you who aren't familiar with either of them, it allows you to do things like, hey, I have this array of things. I want to find the object in there that has the ID that's equal to my ID, because I don't know which one it is, and it'll do it. It made it a lot easier than writing your own loop and writing all the search code and doing it every time you needed to find this thing. So it's a beautiful thing. And I also use another library, Node.js. I mentioned generating unique IDs. I didn't want accidental, awful things to happen when I generated enemies and they get mixed up. Does anyone have any questions before I move towards code? Things like that? About Node? About those things? No?
Pattern programming, which is the fact that you can, for instance, when you make a multiplayer game, you can send stuff to the server, and it doesn't have to log in that database for everybody to call up. It just somehow statelessly gives everybody information based on what other people are doing.
I wouldn't say that there's no database, because there are definitely database drivers. People are definitely still using databases. One of the things that's beautiful about it is similar to the reasons why, if you're familiar with Nginx, Nginx is being used by a lot of people because it's lighter weight than Apache. It's non-blocking, which means that you don't have a finite number of connections that can come in and cause your server to crap its pants, basically. So it's one of those things that when you're doing APIs where you're having a bunch of developers hitting it, or you're doing real-time communications and you want those fast in and outs where, if something gets stuck, it can still take in other communications. That's really, and I am no authority on Node.js. This is the one big thing I've done, but I spent months researching and then writing, and more late nights than I want to count, working in it. But it's one of those things that it's got advantages that other things aren't giving right now. One of the things that I liked about it myself is, with a lot of different languages, you have the issue of serialization. Well, this type you have to coerce this free-form JSON into some type on the back end, and here you're going from JavaScript to JavaScript, so the notation on the structure on the front end is the same as the structure on the back end. And so I don't have to give these, these my data contract becomes convention. I can say, I want to say that this data message is going to have a room ID and it's going to have an array of characters and they're going to have IDs. And then when I send it to the server, I can say, you know what, I just need the room ID property of here. I don't have to tell the server, about the structure of the rest of the object. I can just start pulling things off. So it has that beauty of dynamic languages, which isn't something that we've seen, with the exception of Rails. Now, you don't see that a lot on the server side. That, and one of the things, I watched a video, someone else giving a much better talk than mine, on Node. The numbers in terms of useful libraries that are out there is just blowing away things like Python and Ruby, because this is the first language, I want to say first language, JavaScript's been around for a long time. It's the first platform that's launched since we had GitHub. and since we had the concept of, hey, why don't we do a unified package manager and things like that. So they've been able to explode growth because they were able to put all this code in one spot. They would put all their packages in one spot. You don't have to figure out who's going to do stuff where. There are a few offshoots that have tried to do things, but they're not growing the way the main trunk of Node is growing. So I don't know if any of you have had a chance to see the game. It's going to be really awful on here, but we're going to try it. So this was the final product, and I figured I'd show you guys where I ended up, and then we can go back to something a little bit more manageable. If my Wi-Fi wants, my page layout is destroyed by the fact that I do not think about the fact of supporting something on a projector resolution. So if you go to azurelogic.com, you will probably see a much nicer formatted page. It's a little better. So basically, one of the features of this, I wanted to make sure that it could scale until the server died, basically. And I wanted to make it scale as far as it could go. So one of the features of this is that none of the state of the game, other than how many rooms and who's in what rooms, is actually stored on the server. So everyone kind of owns a certain piece of the game state. If any of you've played a lot of multiplayer games where someone hosts, there's no host negotiation problems here, because when someone leaves the game, their portion just kind of disappears, and everybody else can continue playing. It has its own issues with it, but it's a more unique data model for doing multiplayer gaming. And if any of you want to have laptops and want to try it out, it's not tablet friendly. I will warn in advance. So if anyone has an iPad, there's no touch controls. You'll just get eaten. But you can also see in here, I don't know if anybody's gone there. We'll find out. So 3 people are currently playing in the game. I wanted to be able to see, everybody that goes can see who's actually playing. So I will join whoever it is in game. Maybe. Oh, it's down here. I'm going to get killed if I don't. So typical developer design. It's not pretty, but it's functional. Basically, you move around, you kill things until you die. And they just keep coming until you all die. I forgot one other library in my presentation. I knew I'd forget something. Has anyone heard of knockout.js? So one of the things I also tried to do as an added bonus was I didn't want to use any jQuery, because as much as jQuery powers probably 70% of the web, I figured it might be interesting to try and do it without jQuery. So all my DOM manipulations are done through Knockout. So unless somebody's using jQuery behind the scenes, there is no jQuery whatsoever that I directly use in the site. With that said, I'm going to go ahead and show you guys a more basic version of this, and if I can get to my command line, make sure that I'm. So like I said before, Node.js and the server's running. One other thing that I like about this, I didn't catch your name. I was going to say the guy in the blue shirt. Joel? Joe. So Joe, one of the things that you asked about is, why Node.js? And one of the nice things here is I can use the same things that I'm used to also in the front end. We talked about using the same things in the front and the back end. One of the ways I started with this was I had no idea what I was doing. I said, okay, can I get a thing from here to there? And can I get something back? And so if I set something from the client, from front end to the back end, you can actually do console.logs here, and they'll spit out on your command line. And actually the way I run my server is I actually pipe all of those into a log that's a rolling log file, and I was actually really happy to find out that I had nothing but that in my log file after my server's been running for like 4 months, which means I apparently succeeded. Either that or nobody's visiting my website and breaking it. Probably more the second one, but I will take it as part credit on the first one. So that said, what we're going to see here is, but I disabled all of the zombies. I disabled the attacks. Just want to get a chance to give you guys the ability to see what this looks like. And by the way, if you download this and start running it and try to do more than about 3 of these, your system's going to hurt. Trying to run 3 canvases plus, actually I think it's more the canvas and not the server, because the server doesn't really take a lot at all. But you start. I actually opened 10 one time, and the whole system just came to a crawl, trying to prove how the multi-room system is working. But basically,
Is that only when you're running the server as well as the client?
yeah, I haven't had any issue. I mean, I don't know that I've had enough people on there to try. I have yet to see how far we can go with this, because with doing the model the way I did and needing so little state on the server and using Node being fairly lightweight, I'm able to run this thing on an AWS micro instance, which, if you're not familiar, it's essentially a single core 1 gigahertz processor and 600 megs of RAM. So this thing runs on nothing and still provides real-time communication. So that was one of the goals, is to see how far we can strip it and still make it run. One of these days, I'm going to post, if I ever get the design nice, I'm going to post it to Hacker News and see if they can bring it down. I would like to see it come down, but I want to watch the statistics before it happens, while it happens, because I want to know how far I can go. So you'll notice that, and I'm going to reload these both real quick.
It is about 9, so if anyone wanted to.
Yeah, if I won't feel offended at all. By all means, from here, and actually, I got about my timing right. I was afraid I was going to go way over. We're not going to get even enough time for code. So from here, we're going to actually look at the guts of the code and things like that. By all means, if you want to go somewhere else, feel free. So I reload one here, and we're kind of in this stuck state, because I already have them on both. I have guys on both of them now, so let me kill one, reload. So let me duplicate and watch. When I come back to this one, you'll notice that it instantly adds a person to the other side, and vice versa. So how I achieved that got kind of interesting. But let's go ahead and dig into some of this. So I want to show you guys what the non-PowerPoint version of a package.json actually looks like. So this is the one I'm currently using. I have yet to have major issues with letting it do any version, essentially, with my dependencies. I wouldn't recommend that for anything you would actually deploy to someone paying you money to do that. You actually might want to control the dependencies for when you do your upgrades so you don't break things. But this has been fantastic, just being able to grab just the pieces I need. So in the app.js, this was the server side of this, and the server is actually the slimmest piece of this. After I stripped it of some of the extra pieces that I would use for the multi-room support, what we're looking at here is just how to operate a single room. I can do that in 80 lines of code. That includes the server setup and actually starting the server itself. So there's a pattern here, and this could be a whole other half hour. But require.js, there's this require pattern that essentially allows you to import modules. In other languages, this is your imports. In Ruby, it's your require. I've done so much C++ and I can't think of the word. Include, yes. It's your include in C++. But basically, you can import these pieces and stick them into a variable here and then consume them. So just like I showed in the PowerPoint, that essentially is my server object. This is the express.io syntax. Express itself, I believe, is the first 2 parts. The .io is express.io's magic surrounding that. There's a little bit here to set the port, the view engine, and the less middleware for handling the CSS and things like that. If you actually start with a stock Express project, this is like 3 times the size because they just have a bunch of default options for like session handling and stuff. That was one of the reasons why I liked Express. And so I'm going to jump to the bottom because I want you guys to see, essentially this is the startup on the server itself. And in this example, this is the one route, essentially is the root route for my website, for the website. And it renders the index. This is basically saying, go out and render my index.jade file and pass into it this variable for the title. Which if you look at index.jade, it's not actually a complete HTML file. If any of you have ever worked with like master pages and stuff, there's actually a layout.jade that is the very first line of index.jade. It says it extends layout. So this stuff essentially is just components that go into the layout file. And so doctype 5, that's essentially all your doctype junk that you end up needing to try to remember to do exactly right at the top of every HTML file. Doctype 5, done. You'll notice that there's no brackets around anything, and that this has an appearance of being white space delimited because white space actually is very important here. So basically it's saying that HTML has inside of it head and a block content. And inside of head, I have a title which equals the title variable I passed in. So you can actually pass variables from JavaScript into here. If you've ever looked at things like other templating languages, EaselJS, handlebars, this is very similar to that kind of stuff that you can do in there. Your attributes that end up on the tags then end up in parentheses and stuff here. But I can import fit into this place. So all my scripts are actually in a single block that I can import into the head section. And my entire body here is actually a separate piece. It's up, another way of doing this would have actually been to stick the body back out in the layout, and then you don't have to worry about remembering every, Jade file has to have a body tag. But, that's up to you how you structure it. This one, I did it this way for the init, so I'd have the init function. I have to try and do that, wonder is that going to be on every page. So the only really important thing in here is the canvas element. And this gives us, and you want to give this an ID because we're actually going to attach to this inside the JavaScript code. That's how EaselJS actually grabs onto the canvas and starts manipulating it. I could have used jQuery to grab it. I chose not to. So that's basically how the views get rendered. And then from there, so you access the site, it goes out, renders the view, sends you back the view, and what you get back is the HTML-ified version of these two combined, and you get back, then you go out and grab these scripts. And so we'll start with main, and there's a bunch of variable declarations up here at the top. And the first thing we do is actually attach to that canvas. So I'm going to grab that game canvas element, and then I'm going to attach the stage to the actual canvas element, and that allows me to do all of EaselJS's magic right onto the screen. The way I organized the game then was every character, this was both players and enemies, I just organized them all into one array that allowed me to search for different properties on them using Lodash, which we talked about earlier. The next big thing you need to do is connect to the server. And so that's a single line of code, io.connect, and then the return from that is actually a socket. And that socket then you can use to track incoming messages from the server as well as send messages back to the server. And so first thing I do is I register my callbacks. So what do I want to do? I want to load my rooms in ID. When I join a room, I want to start the game. When I receive something that is game data, I want to what I'm going to do is I'm going to go handle game data received from the server. And when somebody disconnects, I used to have a different callback in here, but in this case we'll just say handle player died because we want to remove them from the stage, clean up after them, and make it so that somebody else could enter the game if they wanted to. The background then, you can load basically if you've worked with other things kind of like jQuery and things like that, they have their one big object, and EaselJS's object is create.js. And so you can instantiate a new bitmap, you basically give it a path relative to your website. And so in this case, I stick this at the background, and we'll get back to seeing how that gets attached. Now, has anyone here done game development? Much game development. Is anyone familiar with sprite sheets? So the idea, I researched a bit of this. I had never heard of sprite sheets that much before doing this. So this was an interesting education. One of the things that people do to reduce the weight of the resources, especially in the web, if I need to make an animation that has 30 frames, I could request 30 separate images, which has the overhead of calling 30 separate network requests and doing all those loads. Or I can pack them all into one image and then slice it up on the other end. Reduces your network overhead, and it's something that ends up making this a lot more efficient. So I learned how to use a texture packer, and I learned how to slice it up, and so all that gets handled in here. But basically, you want to load that image. And from here, so the way we need to think about this is essentially this initializes, and I'm trying to remember the exact sequence of things. And this is where this gets dicey, and the presentation may take a total dive. Notes that I mentioned registered on this side. So they may not be the same names. We have player connect. So this is on. This is the one I'm looking for. Yes. This one's the one on the initial. Oh, that's why. Sorry. I omit player connect. That's what I'm looking for. So we actually send a message to the server that we connected to saying, I want to connect. The server is actually out there listening. Says, okay, I'm going to take your request. I'm going to put together a data message. And I'm going to send back a reply with that data. Now in this, originally I had a bunch of room information about rooms going back and forth, and then, hey, this is the room you went to, and stuff like that. And if you go take a look at the full-fledged code out on GitHub, you'll be able to see that a little better. But anyway, we go to. Oh, so once we've gotten the reply from the server, we actually can go through and set our room that we want to join. And previously, that was the room ID that one of the room IDs we got from the server. In this case, I've hard-coded the room. We say, I want to go ahead and join this room. We go back to the server and say, join room. So this join here is not calling some other strange piece of my own code. This is actually calling into one of the methods of express.io. And this allows us, what socket.io allows you to do is you can do broadcasts to everyone. You can do broadcasts which can include yourself or not include yourself. The difference there is whether you use the request or the app as the starting point. Request.io will actually broadcast, when you do broadcasts on REQ, that sends out to everyone but you. If you do it on an APP, that sends it back to you as well as to everyone else. So one of the things that makes multiplayer, multi-room games possible is this concept of join and room scoping. So you can say, I want to broadcast to everyone, but only the people that have joined this room. And so that's what this broadcast room. And then to everyone in that room, nope, that's not that part. We need to send back to the person who joined, hey, I have officially joined you. In the actual full-fledged code, there's restrictions that you can't have more than 4 people per room, so I would send back a reject message or an accept message just in case 2 people clicked in the same room that already had 3 people in it. So moving on, this is one of the hard problems that I found in here, is what happens when somebody disconnects. When you pull the plug on a machine, it doesn't have a chance to send one last message to the server saying, hey, I'm leaving. The connection's just done, and eventually, your network library says, oh, this person disconnected, but you have no information about who they were anymore, things like that. And that's one of the beautiful things about JavaScript's closure scoping. So this is the only spot that you'll see where I actually define Yes. Where I actually define one route inside of another one, and I define it in more of the original original socket.io syntax because I had to in this spot. I'm essentially capturing the person's initial connection request, which has their socket ID in it, inside of this closure scope. So when the disconnect event happens, I have their socket ID and I know what room I can know what room they were part of. I actually use the socket ID as the player's ID so that I can keep track of who's who and which socket they were on. And so when that disconnect event fires, I have access to the room IDs and to all their information, including the room ID that was originally sent in their initial connect. So I can then notify the people that they were playing with that they disconnected and kill that person off of all those other games. Does that make sense? That one took me a long time to figure out. As I got closer and closer to hitting the point where I was going to implement the disconnect feature, I said, how am I going to do this? And I was actually terrified that the guy who wrote express.io had hidden too much of socket. And it turns out he recommends that you not touch the socket object, but if you want to do this, you have to touch the socket object to do it in closure scope, because otherwise you have to find some way to track it.
Can you make it so that if a player disconnects, he gets put right back in the game with that?
You know, I never thought about. I mean, I'm sure that with spending enough time with that, you could. You'd probably want to. You'd have to have some persistence, you know, because you wouldn't unless you're storing more state on the server to begin with, not with the model I'm using, because the server doesn't know anything about what's going on in anybody's games right now.
You're not using the database now.
Right. And I'm not even even temporarily in memory storing anything. Like another model to do this kind of thing would be like the MMO model, where, okay, we're gonna on the server, we're gonna know who's where, what they're, what enemies we've spawned, and those things. So if somebody walks into the screen suddenly, now I can tell them that there's a monster there and how many monsters and things like that. But then the server has to know about the entire state of the game, everywhere. And I wanted to avoid needing to rent that kind of server to power this kind of thing because I wasn't getting paid for it. So AWS account spun up that instance, and I wanted to find a way to make use of the tiny little micro instance that I had available. So that's how I implemented it. I'm sure you might be able to wizard up a good way to extend this model, but I'm not going to, we get.
Do you know if Node.js is resource efficient when it comes to making like a multiplayer game or a massive multiplayer game versus other options that have already been? I mean, it's nice that you can create it in the browser.
I don't know that I can answer that one. I don't know the memory and performance characteristics of this. I mean, if you ask anyone about performance, they really just knows what they're talking about. They end up just saying, just do it in C++ or C and
Right.
be done with it, And if that's still not performant enough, then write your own assembly and good luck. Godspeed. See you on the other side.
My dream is, making games and, with the web. I think everything's moving that way.
The other danger, and I'm going to put this out there with this model, and I would invite you to explore this model, but also explore other models, is I have made all of the game data now. Like, players create their own enemies, and I don't explain that in this code that we have here. I need to try and... Are we way past? No, we have 50 minutes. So. Okay. The way I ended up generating enemies is every player generates, because now damage has to be shipped back. And what if I kill something here, but an update's already on its way, and then it recreates? Somewhere in there's a dead character IDs array, and that's how I tracked it every three. For the last 5 seconds, I tracked the dead characters, and then I clean up, I chew off. It's essentially like a queue kind of thing. I insert at one end, and everything older than 3 seconds gets wiped out. Because I started to have this problem where I'd kill something, and then it would revive right in front of my face, which is great for a zombie game. I mean, hey, it came back to life. But that was not the goal. But the whole point was we need to be able to kill things and make them stay dead. So that didn't work out so well. So I had to find a way to, essentially in some respects a hack to make them stay dead and, let the messages that were on their way come in, hit a wall, drop off, and clean up. But yeah, I'm sure there's ways to do it, but this model is not one I would monetize necessarily. Because there's too much of the guts available to the user, and JavaScript is very manipulable. I mean, someone could just rewrite this and, say I have infinite, kill the line where you take damage, and suddenly everything's all good for you. Just run it with that JS file instead. So, there's trade-offs here. This was more, it was a school thing. It was an academic exercise in proving that I could do all of these things, and actually complete the project and deploy. So, I won't dwell on it too long. If you want to talk more about it, I'd be happy to talk a little afterwards. So I've lost track of where I was going. I want to make sure we handle a few other things. I don't want, for the sake of time, to explore this block. But I will tell you what it does. This is how you chop up that sprite sheet. And elsewhere in the code, you'll find how then to take, essentially then you can reach in and say, actually down here, I can say, these are going to be my animations. I need you to take, so for my blue gladiator, his walking animation is 1, 0, 2, 0, and that is stand, 1 foot forward, stand, other foot forward, and animation and things like that. This is tricky because this is probably one of the places where, if I remember correctly, EaselJS's documentation is not as good as it could be. It does not really explain how to chop up a sprite sheet, and I found other articles, blog posts and stuff that helped me do this better. But it's still tricky to get. This, I think, was one of the hardest parts, was getting the syntax just right for how did it want this object to look. There was a bit of that, yeah. And then when it's all, and there's a little bit of stuff here, so you have to take the sprite data, and then load it into a sprite sheet object, which gives you your sprite sheet. And we're going to end up using that somewhere around here. But anyway, I want to try and make sure I give you guys a chance to see some of the other pieces of it. So, start game, we end up, one of the things that is important here is timing. And if you just say, hey, I want you to loop endlessly while we're playing the game, that doesn't account for, let's say there's a speed up or a slowdown. Like, let's say you opened up, something else opened up in your computer. Well, during that loop, things slow down, and basically it's kind of hard to explain if you haven't done it before, but until you've seen it actually happen. But essentially, certain frames start getting processed faster because every time it runs through the loop, it moves your guy a little bit. So if it runs through the loop faster in 1 second, then your guy moves faster, and then all of a sudden something slows down, and so now it's only completed 10 loops instead of 100 loops, and all of a sudden your guy slows to a crawl, and you don't understand why. And so keeping track of timing, when was the last time I ran through this loop, and then moving things based on a factor of time is something that actually becomes critical in game development. I didn't learn that until after I got started doing this. You need to keep track of key presses. So this is a little important piece here, is working with that stage. And this is one of those, this was that canvas element that I've done it. You can remove all event listers. This is essentially resetting the stage for a new round, because I would rerun this code every time that I would start a new game, because you can pop in and out of games back and forth. And so first thing you need to do is add child background. And the reason that you have to do this now and never do this again is because the way that the layering works, when you add a new child, it comes to the forefront layer first. So if you have a bunch of stuff moving around and then all of a sudden you slap the background on, now you can't see anything. So you never want to actually remove this one. So once you've done this, don't remove all children again unless you re-add your background before you re-add anything else. For the player colors, I set up convention for how to handle those. This is another one that will save you a lot of time, is they actually have the ability to generate flipped frames for you in EaselJS. So I drew all of my guys pointing to the right, I think it was, left. And this allowed me to have it generate the flipped frames for me, and then they just, by convention, all the frame names we saw, like walk, blue walk, etc. All of a sudden now I have flipped animations, and I can say blue walk underscore H, and now I have access to the flipped one. And now I have, I had to generate that many fewer frames in Photoshop and put them on my sprite sheet and all that junk. Here, one of the things you also have to do to handle key presses is you have to attach to the actual DOM And so you grab the document itself and you get its on key, your on key down and on key ups, and that allows you to handle what happens when someone presses the key and then to stop motion when they release the key. And I'll show you guys a little bit of how one of the slicker ways I handled that. Here's another two important ones. This RAF I'm only going to get into a little bit because it still somewhat boggles the mind and how much I understand it. But essentially, this allows more modern browsers to tap into graphics acceleration to make sure that the canvas runs smooth. So you can set a frames per second as an ideal target, but that doesn't mean it's going to happen. But if you're running a system that has a more modern GPU, you're running the latest version of Chrome, you can tap into request animation frame. That's what it stands for. It allows it to actually sync up some of those changes and accelerate some of that with the hardware, which makes it run a lot smoother. Not smooth enough to run 10 copies at once, but a little smoother. And then this is essentially, as much as starting the server is important to making a server run, starting the game loop is what makes a game run. Is you have to iterate over the same code, checking for events and things like that. And this is what you do. To do that, you tell the ticker that it has an event listener tick, and then, or if it doesn't have it, add one where when the tick event is fired, we call this tick function. It probably would have helped if I actually called the tick function something different than the tick event. And then that's where we get to the main loop. So we talked about timing. Basically what I do is I track the last time. At the end of the last loop, I take this now and I copy it. I say we're going to keep a hold of this. And when the loop runs the next time, I need to know how long it's been since the beginning from the last beginning to this beginning. And that tells me how much time has elapsed relative to other loops. And then I can scale my movements based on time. And getting the equation right is something that involves a lot of fiddling. You say, well, let's try 1. Okay, let's try 0.5. Let's try 0.01, and so we end up passing that time around a lot. For example, with the motion, we want to move the characters by a factor of that time. This was another thing. When players moved in front of each other, they set, when they were in, we were talking about how things get added to the stage. When player 4 joins, and he's in the back, further into the background of the game, he should not be overlapping a guy that should be farther in front of him. So
what happens if some smart aleck sets the clock backwards?
while they're playing, that's going to throw a wrench in things. Well, actually, it would only throw a wrench in things temporarily, though. I track a couple different times because I don't want to generate enemies every second. I generate them every so often. I only allow them to retarget every so often. But it would throw things off for maybe a couple seconds, and then it would be back to normal because we continue to track the current time. So eventually it will wash itself out. Doesn't mean that things won't get weird in the meantime.
Well, if you say you're trying to count backwards.
Now you're just messing with me.
What if MKP takes
So one of the tricks I realized, I was like, well, I'm going to have to sort these things, and I have all my bad memories of writing sorting algorithms in C++ came back, and then I had a really great idea. Why don't I just strip the stage, re-add the background, and then re-add all the characters in order, sorted by order of their y coordinate on the sprite. And because I was going to have to rearrange all the characters anyway, why not just strip them all and then let it take care of itself? So this was a way that I found that was a little bit slicker to rearrange my stage. Another thing I found that might be an issue is the concept of, well, what happens if somebody doesn't move for a while? They're not sending messages to the other side. And so the concept of a heartbeat becomes important in multiplayer games where, well, if nothing's happened on someone's system in half a second, let's still send an update because, enemies may have moved positions and stuff. One of the things I realized early on was if I on every key press sent an event, you should have seen what happened I was logging this stuff in my terminal, and just the stream, I was logging them so I could actually see the difference. I was logging the timestamp on it, and just the stream of communications. We talked about trying to keep that small server alive. We would have crushed it to death under the weight of just, because if you think about a key repeat on a keyboard, it's like 20, 30 times a second, something like that. So 20, 30 seconds of messages per second per player. Yeah, didn't sound very good. So I decided that only in certain cases when they change directions, we should send a message. Every time there's a heartbeat, every time someone attacks, those are things that are key elements that we send messages on. So I don't want to. I'm almost about to overstay my welcome here. I want to make sure I give you guys a chance to see a few other important pieces. So one of the things I did with the key handling, I found that both my key up and key down did all the same things except for the specific details of the key press itself. And so what I did was the key down calls another more generic method that takes in a function that actually handles the specific key presses. And so it sends in this callback here that handles the different key codes and whatnot. There's an important lesson to learn here is you want to make sure that you have a return at the end that only returns true if it's not a key that you're trying to capture, because you will no longer be able to access your developer console. Because if you capture all the key presses, you can no longer you can do it, but you have to go through the menu to do it. I started to wonder why I can no longer access my developer console, and that's an important lesson that I learned there. I found out that the browser actually expects to get that key press, but it gets swallowed by your JS first, so you need to pass that information back out. The handle key up does the same thing, and then in handle key signals, I actually send in switch handler, which gets executed in the middle, and sends its return, which gets sent back to the browser. It's a big chain of callbacks, and this is why we talk about being in callback hell these days, is because of things like this. But it made the code a little bit cleaner at the time. So here's one other important piece is, so how do we communicate while the game's happening? And so earlier in the main loop, maybe, under certain conditions, if I've set this send local player motion for certain events, I would send it. Or if the heartbeat has been more than 500 milliseconds, go ahead and basically let's go ahead and track when we sent the heartbeat. Let's shut this one back off, and let's send the game data to the server. And that is what happens down here. And so here you create a convention. You could actually create an actual proper class for this, or I just did it with anonymous objects. But basically, you create your data contract here, where you say, you want to include the room ID because the server needs to know that, and then you need to send the player IDs because the other players need to know that kind of stuff. Then you pack all the player data that needs to go with it, their position, which way they're facing, what's their current velocity, things like that. And then we go back to that socket and send it on one of those routes, which then ends up being picked up by the server and rebroadcast to all the other clients. And then what has to happen, this is a callback that's actually hooked to the other event. So I did client send here. There's a client receive event that has this as a callback, and we unpack that data. And so doing that kind of stuff, you got to make sure that one of the ways I handled player creation was, okay, I joined a room. Well, when I don't know about a player, just make one. Or when I don't know about a character, make it. Just make it happen, which is where I ran into problems with dead zombies suddenly got reanimated because, well, I didn't know about it. It was dead. So we remade them. If we do know about them, so you have to find it locally, and there has to be the player data actually has to exist. Then we update the local version. So basically, what's happening here is, my motion models actually include both position and velocity, so you can approximate the trajectory of an individual character. And you don't do it at full speed because if they change directions, you end up with things jumping around on the stage. But it ends up being a way that you can approximate things in case you end up having lag in certain spots in the network. It still allows you to have relatively smooth motion in the game without trouble. I did all my object-oriented stuff in a whole other class, and I don't really, this stuff handles a lot of the animation stuff, a lot of the motion. Notice that, when we call the move method, we're actually moving based on a time factor. And then we also I used a constant for whether they're moving left or right because left is just negative, whatever the value would have moved right. So you essentially be able to start being able to do this. Diagonal motions, a special case you want to handle if you offer diagonal motion. If you let them move at full speed at diagonal, they actually can run faster at a diagonal. So you need to put a square root of 2 over 2 on each of those sides. You want to bound your characters inside of the stage. Trying to think if there's any other really interesting things in here. Does anybody have any? I don't want to. I know we're running past, and I don't want to forgo questions. If anybody has questions.
Can you layer character sprites on the Y position? Do you know by ID if they all have the same Y?
If they both have the same Y, I used the built-in sorting from underscore, so whatever it did, I accepted. If they were that close together, I mean, we're talking pixel for pixel, then I let it do whatever it's going to do, because there's no, it's that. I guess I would say I accepted the level of how far I could go with it without extreme difficulty.
What license is this on?
I don't really care, but I'd appreciate if you credited me if you use your code, if you use my code. I should probably put a license on this, but if I do put something on there, it'll be something fairly permissive. I forgot about that. I actually thought about it, and I should have anticipated that question. My GitHub page doesn't explicitly say, but it's I suppose just if you credit me, I'd appreciate it. But yeah, that's a good chunk of it. If you want to see all of it, you can go check out like I said, you can check out the master repo, the master branch on my repo, which is at my GitHub. And feel free to check out my Twitter. I don't talk too much about really in-depth things on there, but I like to repost articles, probably from Hacker News. But feel free to check out. This stuff is all on, if you want to see a more simple version, check out the rollback branch on Retro Roman Zombie Apocalypse. It's the only repository I have out there right now. If you want to see the full thing, you can check out the master. Any other questions? No? Thank you guys. I appreciate you all sticking around. And I'd be happy to talk